Well, this recording will get us through some of the technical issues we had in class today between me trying to find a room that worked in the Science Center and then not being able to load my.usf. So I wasn't able to load an Excel file that I wanted to use during the class today to show you guys how to do some of the homework problems. So I'm in our class. You're in either ACC 332 or BOS 332. Under both of them, click on Resources, under Resources and Downloads, so Resources, Downloads, and scroll to the very bottom, and then you will find the PV and FV formulas Excel file. And I've got it open right here, and so when you open it up, it looks just like this. This should look familiar to a lot of you in managerial finance. I use the exact same file. And if you recall, what it does is it helps us with a lot of present value and future value concepts in terms of ordinary annuities, annuity dues, present value and future value amounts. And we're going to use just a couple sections when it comes to bonds. So this chapter deals with bonds to some degree, and a part of that is the fact that a bond is always an ordinary annuity. So that's one thing to kind of keep in mind. Okay, so bonds are always ordinary annuities. So I'm going to go back to the book, and I've got the ebook open, and I've got it right here. And so let me get rid of that. And so I'm just on page 616, exercises 11-1, and you can see here the first one we'll take a look at. So I'm just going to cover the problems that I could not cover in the classroom because I needed that Excel file to use, and it wasn't available to me because my .usf was down. So the first one is Akers Company sells bonds on July 1 of 17, face value of $100,000. Bonds are due in 10 years. Stated interest rate is 6% per year. So remember that stated rate is the rate stated literally on the bond contract, and that's the amount used to calculate the cash paid in interest. Payable semi-annually, that means twice per year, on June 30 and December 31, and the bonds were sold to yield 8%. So that was the market rate of interest the day that the bonds were actually sold to outside third parties. So the question is, would they sell for the day they were sold of July 1, 17? Okay. So I'm going to go back to Excel, and we'll go ahead and complete this section right here, the present value of an ordinary annuity, because that's what bonds are. There's several sections to complete on this file. So the payment deals with the cash paid for interest. So the face value of the bond, basically what it matures for when it will mature in 10 years, is $100,000. The payment then is based on a 6% interest. That's the stated rate of interest. So times 0.06. And then you have to double that because it's semi-annual, which is every 6 months. So basically it is taking 100,000 times 0.06 / 2, and you get 3,000. Okay. The future value is the face value. It's what the bond will mature at when it becomes due in 10 years. The interest rate is the market rate of interest. So when they mentioned back in the problem, the bonds were sold to yield 8%. That's the market rate, and that's what this number is. So it's plus 0.08 / 2. So it becomes 4%. And then this is a 10-year bond, and obviously 10 years multiplied by payments are made twice per year. So 10 times 2 is 20. And I get the answer, what the bond is worth, of $86,409.67. Now, keep in mind that most likely when you do these in McGraw-Hill Connect, that they'll ask you to actually do them as whole dollars. So if I just take the decimals away, it rounds to 86,410. So most likely you will not be using pennies in your answer. So just be aware of that when you enter that. So just to kind of recap, the payment is the principal, the face value, times the stated rate of interest divided by 2 because it's a semi-annual. The future value is the future value, just what the bond will mature at. The interest is based on the market rate of interest divided by 2. And then the number of periods is the fact that it's a 10-year bond payable twice per year. So it becomes 20. And the answer is 86,410. Okay, so 86,410, the answer to question 1. Then question 2 is basically just saying the same thing, the same question, but they're just adding one little change to it. and it says we've moved 1 year, it says here July of 18, the market yield on the bond is risen to 10%. So what's the bond's market price 1 year later? Okay, so the bond was originally issued July 1 of 17, now it's July 1 of 18, and the difference is the market rate of interest is now 10%. So how did that change the market price of the bond? Okay, so the payment's the same. It's still the stated rate of interest is always the same. Future value is the same, no change. The market rate of interest, though, has become 10%. So instead of 0.08 divided by 2, it'll be 0.10 divided by 2, which is 5. And now we're 1 year down the road, so there's not 20 periods left or 20 payments left. We're a year later, so it's 9 years times 2. So 9 times 2. Okay. And that gets me to our new answer, which is 76,621. So just 1 year down the road, the market price of the bond has changed for 2 reasons. There's only 9 years left till maturity, and the market rate of interest has increased from 8% up until 10%. Okay, then question 3 is another one that I wanted to go over with you that I could not today in class. It says here in January 1 of 17, the market rate of interest was 14%. Luba Corporation issued bonds in the face amount of $500,000 with interest at 12% payable semi-annually. So the market rate of interest is 14. The face amount of the bond maturity value is $500,000. Interest is payable semi-annually at 12%. The bonds mature in 2026. That's literally 10 years away. Okay, so it says December 31, 2026. Well, it's 10 years between January 1 of 17 to December 31 of 2026. So we're kind of just throwing us off the trail just a little bit with that. So it says calculate the bond discount amount and how much of the bond should be amortized by the effective interest method by July 1 of 17. So basically 6 months after the original bond issue. So we'll go back to the present value of ordinary annuity. And so the payment is based on the principal of $500,000 times the stated rate of interest of 12 divided by 2. Okay. And that's $30,000. And then, so yeah, 500,000 times 12.12 divided by 2. The future value is the face amount, the maturity value, 500,000. The market rate of interest was 14, but I divide that by 2 because, again, it's semi-annual. And then this is a 10-year bond with 2 periods per term, so 10 times 2. I get 447,030 is my answer. That's what the bond is worth the day we sold it. And so, of course, the discount would be the difference between the two. The discount is the future value of 500,000 minus the present value on the date the bond is sold. So basically the discount is $52,970, and that should really just all be in whole dollars because that's how you'll most likely be entering it into Connect. So then the next part of the question is, so 6 months later, how much amortization is there? What is the, so let's go back to the question. So in 6 months later, so this is question 3, how much of the discount should be amortized? Okay, using the effective interest rate method. So this is the discount. So so let's go back to the date period being July 17. So let's go July 1. So 7/1/17. That's 6 months after the bond was issued on January 1 of 17. And we have to calculate interest expense and interest payment. So interest expense and interest payment. Okay. So interest expense is based on the market rate of interest. Okay, so the 7% right there, that's the market rate of interest. So I multiply that 7% times the value of the bond right here. Okay, and that gets me to 31,292. And let me just get rid of the pennies here. Okay, then the interest payment, the amount paid for interest, is the 30,000. Every 6 months, 30,000 is paid. And so the difference between the two, 31292 and 30,000, is 1,292. Okay, and again, that would just be in whole dollars. So that is the amortization right there. So the difference between interest expense and interest payments is amortization of 1,292. Okay, so then in 6 months, the bond is worth the 447,030 plus the discount of 1,292, which is 448,322. Okay, there's just one more question that I wanted to go over that I was not able to in class today. It's 11-8, called a zero coupon bond. And this is just kind of to represent the fact that even if there isn't really interest stated in the bond, there really is interest. And same thing with the note payable, anything like that. So anytime there is borrowing, there is always interest. Okay, so that's just what I want you to kind of walk away with from this problem. So it says here, a zero coupon bond pays no interest. The only cash investors receive is a lump sum principal payment at maturity. On January 1 of 17, the Ledge Inc. issues a $250 million zero coupon bond at a market rate of 12%. That's the market yield, and it matures in 20 years. So what is the issue price of the bond? So with this one, we have to figure out what's the present value of $250 million at 12% over 20 years. So go back to the Magic Excel file, and you want to find the present value of an amount, which is this one right here. So this is 250 million. Oops, there's no payment. That just saves the zero, my bad. So the future value is 250 million. The interest rate was 12 over 20 years, and so and this should be in millions, so I need 3 more zeros. So $250 million, 12%, 20 years. The present value of that is $25,916,691. Okay, and again, that would just be in whole dollars. $25,916,691. And so that is what the bond would sell for question 1. So going back to the question, that is the issue price right there, that $25,916,691. Then question 2 is how much interest expense will they record in 2017? So they issued the bond on January 1 of 17. So for the full year of 17, what is the interest? Okay, and that one's not too tough to figure out, thankfully. So it's just really a matter of taking that 25,916,691 times 12%, and I'm just going to multiply the two out. So that amount times 12, and that's the answer right there. Okay, and again, we'll just do that in whole dollars. So it's 3,110,003. That is the amount of interest. They didn't mention anything about this being semi-annual in the question, so we can just assume it's an annual interest. So now they don't pay that interest, right? But they have to record the fact that interest is being incurred. Okay. It's the same thing for 2018. How much interest expense is there for 2018? Well, in 2018, what I do is I have to take the original amount, the value of the bond when it was issued, 25,916, plus the interest from 2017, those two numbers, and I multiply that by the 12% again. So my 12% times the new amount of 29, and I get my interest in year 2, which is 2018, now becomes 3,483,203. And I would just keep on doing that every year. And then that writes up the bond also, right? So that by the time the bond matures, we've recorded interest expense every year, and then we would record the repayment of the bond at $250 million in the 20th year. So kind of imagine how that works. So to borrow to borrow 25,916,000, you have to repay $250 million in cash in 20 years. Okay, so that's what a zero discount bond looks like, and that's how they work out. Otherwise, that was it. The those are just the problems that without me having the ability of having that Excel file, and of course, if we would have been the Cleveland Center today doing this class, I would have had that Excel file is on my flash drive that I keep with in my office all the time. But because we were in a different building, we could not do that. So hopefully that all made sense. Obviously, if you've got questions, just let me know. Thanks.